Good morning, guys. It is early in the morning here at Clear Creek High School, and I'm going to record our video over 10.2 over stoichiometry, which is not only a very fun word to say, but is also a very fun thing to do. Um, what is stoichiometry? Stoichiometry is the math behind taking you from one unit of a chemical, so like grams of something, grams of water, grams of hydrogen, grams of whatever, and figuring out how many grams or whatever other unit of something else you have. So it's when we start in one unit and we convert to a different unit. So we start with like water and you convert to hydrogen gas. You start with whatever and convert to whatever. So when we're doing these conversions, we are going to only be using our three main conversions. We're going to be using the one that will take us from moles to atoms and molecules, which is this one here on the right. That's JK, that's your left. Hold on. Okay. One on your left is the conversion between moles and atoms, or moles and molecules. The one in the middle converts from moles to grams, and then the one on the far right converts from moles of one substance to moles of a different substance. That's what the A and B stand for. A stands for the substance that you're given. So like if we were given water, then A would be water. And B stands for the substance that you're converting to. So if you were converting to like hydrogen gas or oxygen gas, that would be your B. There's a typo here. It should say mole map. These are your steps. Stoichiometry steps. Steps to stoic. That's also a really fun word to say too. And sometimes when I'm trying to say psych, I end up saying stoic, which is kind of funny because it's chemistry. Anyway, so let's go through the steps. If you're given a question like the one on the below, it's the guided practice problem. It says use this chemical equation to calculate how many grams of water are formed from 34.2 grams of lead oxide. The very first step that I always tell students to do, we actually don't have to do for this problem, and that is write the reaction. So this reaction like has already been written for you. Like we already have our reactants and our products written, so that's kind of nice. But the second step we actually do have to do, and the second step is balancing. So sorry, my handwriting is the worst. So we have to balance our reaction, which just means that I have to make sure I have the same number of atoms on both sides. So on the reactant side here, you can do like a little reactants chart and products chart. On my reactant side, I have lead, Pb. I also have oxygen, and then I also have hydrogen. And then I have the same elements on my product side, lead, oxygen, and hydrogen. And so, like, you've noticed, I haven't done anything really with the problem. You don't do anything with the problem until you've already written your reaction and balanced it. So that's why we're doing this first. So on the reactant side, I have 2 leads. So I'm going to put a 2 here. On the product side, I just only have 1 lead. So I need to double that. So if I put a big 2 here, I now have 2 leads on both sides. So they are equal. Okay, and so now I'm going to look at my oxygens. Now, here's a good question. Why am I looking at my oxygens first? Oh, I forgot, guys. There's also SO4. Now, the oxygen in SO4, I'm not actually going to count as one of my single oxygens. I'm going to count it as my polyatomic, because anytime you have a polyatomic, you keep it together if it's on both sides. So SO4 goes here and SO4 goes here. Now, we should have learned that oxygen and hydrogen you balance last. So look at the SO4s. How many do we have? Well, I have 1 SO4 here and 1 SO4 here. So 1 and 1, those are balanced. Now I can go to my oxygens and hydrogens. Which one do I want to balance first? Well, I want to balance hydrogen last because it's by itself. It's a single. So let's do oxygen first. I have 2 oxygens here. Okay, so 2. And I have 1 oxygen on this side. So I need to add another oxygen on my product. So if I put a 2 here, that'll be multiplied, and I'll have 2 oxygens. Okay, so now lastly, I can look at my single hydrogens. Here I have 2 single hydrogens, and then this 2, when it multiplies by that, I actually have 4 on this side. So in order to get 4 on the other side, I need to put a big 2. So it'll multiply by that, and I'll get 4 hydrogens and 4 hydrogens. So my third step when I'm solving any stoichiometry problem, after I've written the reaction and I've balanced it, is to put my given over 1. So the given is the number that is given to you in the equation. And so when I'm reading this, not the equation, I'm sorry, it's the number that's given to you in the question. So when I'm reading this question, it says how many grams of water, there's no number there, will be formed from 34.2 grams of PbO2. There is a number here. So the unit and the number are going to be my given. So I'm going to put that over 1, 34.2 grams of PbO2 over 1. Okay, so my fourth step is it's called trace the path. So what do I mean by tracing the path? Well, our given right here is grams of PbO2. So I'm going to write that here. What I want to get at the very end is grams of water. So I have to trace this path between grams of what I'm given, PbO2, and grams of what I want to go to, H2O. So the first step, whenever you're given grams of anything, and this is really important, so you probably should write this down somewhere in your paper. Anytime you're given grams of anything, you need to convert it to moles first. That's always your first step. So if I'm in grams of PbO2, I have to go to moles of PbO2. That's always my first step, grams to moles. That's if you're given grams. If you're given moles, then you wouldn't necessarily have to go to moles because you're already in it, right? But in this one, I'm given grams, so I need to convert to moles. Now, once I'm in moles of something, how do I get to moles of something else? See, I want to get from moles of PbO2, and I eventually want to get to grams of H2O. Well, let's go look at our conversions. I'm in moles of one thing. I want to go to something else. Whenever you're in moles of one substance and you want to go to moles of a different substance, you have to go to moles of that different substance first. Meaning you have to use this conversion factor because it will take me from A, which in this particular problem, A is the substance that we're given first, which is PbO2. B is the substance we want to go to, which is water. So I will use this conversion factor to go from moles of one thing to moles of something else. So I need to go from moles of PbO2 to moles of water. That'll be my second step. Now my last step is just to go from moles of water to grams of water. So once I've written out my path, I'm going grams of A to moles of A, moles of B to grams of B. Now my fifth step, after I trace my path, is to write out my conversions. And for every arrow, there's going to be a conversion. So I'm going to have 1, 2, 3 conversions, okay? So my first conversion is between grams and moles. So which one of these 3 conversions at the very top will get me from grams to moles? You should say this middle one. So I am going to use 1 mole of PbO2 equals, what does the MM stand for? That stands for the molar mass of your substance. So I have to find the molar mass of PbO2. Molar mass is something we learned in the first unit of the semester. To find molar mass, remember you have to find the number on the periodic table for each element and then add them up. So we would find the number for lead, Pb, and you'd add it up to the number of oxygen, but you would need 2 oxygens because there's a 2 there. So whenever I do that, I'll go ahead and give you the answer. It's 239.2 grams. That's the molar mass of PbO2. So I got my first conversion factor. My second conversion factor is between moles of one thing to moles of something else. Which conversion factor will take me from moles of one thing to moles of something else? This one right here. So I'm going to write it out, moles of, and instead of A, I'm going to write my given unit, PbO2, and then moles of H2O. But do you see the number in front of moles? They're question marks. Remember, the question marks stand for the coefficient. So I have to find our balanced equation and find the coefficients of PbO2 and the coefficients of water. So when I come down here, I see the moles of PbO2 is blank, which just means 1. The moles of water is 2. So now I'm going to write that in. 1 mole of PbO2 will react to form 2 moles of water. So I've done my first conversion factor and my second conversion factor. What's my third conversion factor? It's going from moles of water to grams of water. Which one of these top 3 conversions here, which one of these 3 will get me from moles to grams? You're going to actually reuse this conversion factor up here. The only difference is we're in moles of water and grams of water, not moles of PbO2 and grams of PbO2. So I'm going to write it out. 1 mole H2O equals grams of H2O. So what do I put next to grams? Well, remember, the MM stands for molar mass. So I have to find the molar mass of water by adding 2 hydrogens to 1 oxygen atom, which is 18.01. I really have that one memorized. Okay, so I have 3 conversion factors right now. Okay, I'm going to highlight them so you know what they are. This is one conversion factor. This is the other conversion factor. And this is our last one. So now I'm just going to use these conversion factors and plug them in. Remember when I said that each arrow here represents a conversion factor? Each conversion factor is going to be a fraction. So since I have 3 arrows, I'm going to have 3 fractions to put my conversions in. This first conversion factor is going to be plugged in to this fraction. I just have to decide which side of this conversion factor goes on the top and which side goes on the bottom. Well, since grams of PbO2 is on the top as my given, I would also want grams of PbO2, but this time on the bottom so it can cancel out. So that means 239.2 goes down here because grams of PbO2 goes down there. The other part of my equation was 1 mole of PbO2, so that has to go on the top. Okay, so now I am done with the first conversion factor. What about my second conversion factor? Here's my second conversion factor. That has to go in my second fraction. Which side of this conversion factor do I want to go on the bottom? Well, if you remember of canceling, we already cancel out of grams, right? Because if it's on the top and then it's also on the bottom, it gets canceled out. So I want to cancel out now of moles of PbO2. So what has to go on the bottom? Moles of PbO2 has to go on the bottom. And up here, it says 1 mole of PbO2. That's why I put the 1 down here. Now, the other part of my conversion factor is right here, 2 moles of water. So that's going to have to go on the top of this fraction. Okay, so now that we've done that, we can actually cancel out moles of PbO2, and now we're in moles of water, right? So let's refresh. We went from grams to moles, and now we're in moles of water. So the last thing I have to do is use my third conversion factor to go to grams of water. So here's my third conversion factor. Whoopsies. Okay, I'm going to draw it right down here into my last fraction. So whenever I take a conversion factor and I'm going to kind of put it as a fraction, you have to decide what part of your conversion factor you want to go on the top and what part you want to go on the bottom. So for example, 1 mole of water will either go on the top or the bottom, and then 18.0 grams of water will either go on the top or the bottom. So how do I know, which one I want to go where? Well, I know that I have moles of water at the top right here, so I need that same unit on the bottom to cancel out of moles of water. So that means I'm going to take 1 mole of water and it goes down at the bottom. That leaves me with 18 grams of water, which is going to go on the top. Or 18.01 grams of water goes on the top. And so now my moles of water cancel out. I'm in grams of water. So whenever I do calculate the answer will be in grams of water. When I multiply 34.2 by 1 and then by 2 and by 18, I get the top, I get 1,232.57. And then when I multiply the bottom numbers, it's just 239.2. And then I divide them and I get 5.15, and then my unit is grams of water, right?